So we next start exercises 6.1, and this is the first one. Here we have to solve the inequality 24x less than 100 under these two conditions. In the first one, x is a natural number. In the second one, x is an integer. So we take the inequality 24x less than 100. This is equivalent to this. And we obtain this from this by dividing both sides by 24. Because 24 is positive, the inequality maintains its direction. It does not get reversed. So that way we get 100 divided by 24. Now if you cancel the common factor 4 from the numerator and denominator, you have 25 in the numerator and 6 in the denominator. So from this you can clearly see that your x has to be less than or equal to 4. Then under the condition that x is a natural number, these are the solutions 1, 2, 3 and 4. But then for the second one it will change. So for part 2 we need all integer solutions to this inequality. That means we have to consider all integers less than or equal to 4. That's why we have written like this. So unlike this first case, in the second case there are infinitely many solutions. Next we have number 2, where the inequality to solve is minus 12x greater than 30, and the conditions are same again. In the first one, x needs to be a natural number, and in the second one, x needs to be an integer. So we write the inequality minus 12x greater than 30, and then to isolate x we divide both sides by minus 12. Because minus 12 is negative, so the inequality gets flipped. Originally it's like this, now it's like this after division. And then after cancelling the common factor 6 from the numerator and denominator, we have 5 divided by 2, which is 2.5. So x needs to be less than minus 2.5. And because of that, what was the condition in the first part? That x needs to be a natural number. But that is not possible. X is not a natural number, it's negative. So that is why there is no solution. There is no natural number x that will solve this inequality. And in the second part, x needs to be an integer. Yes, now there are solutions, and the solutions all need to be less than minus 2.5. Now the first integer that you encounter which is less than minus 2.5 is minus 3. So that's why these are the solutions. All integers less than or equal to minus 3. So in the next one, number 3, the inequality to solve is 5x minus 3 less than 7. And the conditions are these. In the first one, this time it's different from the previous one. The first one needs x to be an integer, and the second one needs x to be a real number, which actually is no restriction at all, because anyway x is a real number. So we consider the inequality which is 5x minus 3 less than 7. And then we need to go through 2 steps to isolate x. First we add 3 to both sides. That we can do by one of the rules for inequality manipulation. Adding 3 to the left hand side makes it 5x, because minus 3 and 3 cancel out. Adding 3 to the right hand side makes it 10. 7 plus 3 is 10. And then in the next step, we divide both sides by 5. Because 5 is positive, so the inequality retains its direction. And 10 divided by 5 is 2. So x needs to be less than 2. Now under the condition that x has to be an integer, these are the solutions. All the integers less than 2. You see the ellipses on this side because we have infinitely many integers on that side. Or you can use the set builder notation to write the set. Instead of simply writing the solutions are, we have written the solution set is. This looks nicer. Okay, so in set builder notation, you can just simply write the solution set to be the set of all integers x such that x is less than or equal to 1. But if there is no restriction on x, simply just the fact that x is a real number is there, Then of course the solution set is the set of all real numbers less than 2, which is this interval, this unbounded interval minus infinity comma 2. Next we have number 4, where the inequality is 3x plus 8 greater than 2, and the conditions are as before, like the previous one. In the first one x needs to be an integer, and in the second one x is just a real number. So the inequality this time is 3x plus 8 greater than 2. So in the next step you subtract 8 from both sides, which makes the left hand side 3x and the right hand side 2 minus 8, which is minus 6. And then you divide both sides by 3, because 3 is positive, the inequality maintains its direction, and minus 6 divided by 3 is minus 2. So here x needs to be greater than minus 2. Now under the restriction that x needs to be an integer, these are the solutions, because these are precisely the integers greater than minus 2. But if there is no restriction on x, or x just simply is a real number, then the solution set is just the set of all real numbers greater than minus 2, which is this unbounded open interval minus 2 comma infinity. Next, solve the inequalities in exercises 5 through 16 for real x. That means now there is no more any restriction that x has to be an integer or something else, a natural number. X is just a real number. And the fifth one is this: 4x plus 3 less than 5x plus 7. So we consider the inequality, which is 4x plus 3 less than 5x plus 7. Now in the next step we do two things simultaneously. We subtract 4x from both sides, and we also subtract 7 from both sides, which gives us this 3 minus 7. I mean, if you think of it for a moment, subtracting 4x from the left hand side makes it 3, okay, and the right hand side is 5x minus 4 plus 7, but we were also subtracting 7 from both sides, so that way you get 3 minus 7 less than 5x minus 4x. The aim of course is to bring all the terms having x to one side and push everything else to the other side. That's what we did. If you want, you can do it in 2 steps. I mean, you can really write 2 steps. So this becomes 5x minus 4x, which is x, and this becomes 3 minus 7, that is minus 4. So x needs to be greater than minus 4. And so the solution set is the interval consisting of all real numbers greater than minus 4, which is this open unbounded interval minus 4 comma infinity. And then the sixth one, where the inequality is 3x minus 7 greater than 5x minus 1. So the inequality this time is 3x minus 7 greater than 5x minus 1. So we subtract 3x from both sides. That makes the right hand side 5x minus 3x minus 1 actually, but simultaneously we have also added 1 to both sides. That gave us 1 minus 7 on this side, and on this side minus 1 gets cancelled out. So 1 minus 7 becomes minus 6, 5x minus 3x becomes 2x. Then in the next step we have to divide both sides by 2. Because 2 is positive, the inequality does not get flipped. It does not change direction. And we get minus 3 greater than x. These parts may become very confusing, okay. You have to be very careful in interpreting the inequality. What is it that you are looking at here? You are looking at all real numbers x which are less than minus 3. Although on the number line, if you just simply think of these numbers on the number line, this is not how they will appear, because x being less than minus 3 should lie on that side and minus 3 should lie on this side. Inequalities, however, can be written in any way we want. You can write this same inequality as x less than minus 3. Same thing, but this one looks a bit confusing. That is why you have to be careful. So it is the set of the solution set is the set of all real numbers which are less than minus 3. That means this unbounded open interval minus infinity comma minus 3. And one more thing I want to draw your attention to. Why are we simply keeping on writing if and only if double implication, not just implies? That is because here we want to emphasize the fact that just like you can come from this inequality to this one, you can also go back. What does it all mean? See, this is what it means. You are considering an inequality and then you do something and get a statement about x. What does it tell you? It tells you that if x is a real number satisfying this inequality, if, then x needs to be less than minus 3. But is the converse also true? If x is really less than minus 3, will it also satisfy this inequality? Yes. That is why we are using double implication. And that actually tells us that the set of all real numbers x which satisfy this inequality is the same as the set of all real numbers x which are less than minus 3. Do you see why these two sets are equal? You have proved two implications, right? If this is true, then this is true, which means that the set of all real numbers that satisfy this inequality also are less than minus 3. So that set is a subset of this set. Conversely, you have also proved the reverse implication. If x is like this, that means if x is an element in this set, then x also is a solution of this inequality. So x is also an element in the solution set. So this is also a subset of the solution set, and that is why combining those two containments of the two sets, that each is a subset of the other, we get equality, that the solution set is equal to this. That is why. Next, number 7, and here the inequality is of this type, less than or equal to, and the inequality is 3 times x minus 1 is less than or equal to 2 times x minus 3. So we consider the inequality. Now here there will be one more step because of how it's given. First you have to do the multiplication. 3x minus 3 is less than or equal to 2x minus 6. Then in the next step, you already know we do two things simultaneously. We subtract 2x from both sides, that gives us 3x minus 2x, but simultaneously we add 3 to both sides. So that way we get 3 minus 6 on this side. 3x minus 2x is x, 3 minus 6 is minus 3. So here the solution set consists of all real numbers less than or equal to minus 3. That is why the solution set is this again unbounded interval, but this time closed on this side, because minus 3 is also a solution. Next we have number 8, where the inequality is 3 times 2 minus x is greater than or equal to 2 times 1 minus x. So the inequality here is 3 times 2 minus x greater than or equal to 2 times 1 minus x. Now let me tell you about a psychological thing here. We do not like having minus sign with x. It's a tendency that we have of always having a positive coefficient with x, not a negative one. For some reason it disturbs us, and that makes us multiply both sides by minus 1. Make the inequality look like one where x has a positive coefficient. If you do that, what I said just now, you will get 3 times x minus 2, because you are multiplying by minus 1, the inequality will change direction. 3 times x minus 2 is less than or equal to 2 times x minus 1. Then the inequality really looks nice, and then you do whatever you have to do, but that's just a wastage of time. You work with the inequality as it is, you will see why. So we just simply do the multiplication. 6 minus 3x is greater than or equal to 2 minus 2x. Alright. Then in the next step we do those two things. We subtract 2 from both sides, obtaining 6 minus 2 on this side, and from this side 2 is gone. And we also add 3x to both sides because we have minus 3x on that side. So x is gone from the left hand side, and on the right hand side we have 3x minus 2x. 6 minus 2 is 4, 3x minus 2x is x. So actually that would not really have served any purpose other than just adding an unnecessary step to your calculation, that is multiplying by minus 1. So the solution set consists of, again be careful, all real numbers less than or equal to 4. That means this interval, all real numbers less than or equal to 4, because the equality option is available, so the interval is closed on this side. 4 is also included. Next, number 9, where the inequality is this. It's a bit different from the ones we have been seeing. X plus x divided by 2 plus x divided by 3 is less than 11. We are back to this strict inequality type. So we write the inequality x plus x over 2 plus x over 3 less than 11. And then there is no real need to take LCM and then do the calculation. You straight away multiply both sides by the LCM. I wrote this step just to show you that we are multiplying both sides by 6. That's because I am not writing those reasons alongside, that is with the steps that I am multiplying both sides by 6, or say in those calculations adding 3x to both sides, subtracting 2 from both sides, but you should do it. Okay, alongside the steps you write the reasons in square brackets. But because I am not doing that, so I showed what I did here by writing this extra step. So you get 6x after you do the multiplication. 6 divided by 2 is 3, 3x, 6 divided by 3 is 2x, and on this side you have 66. So you can see that this becomes 11x, which is less than 66 after cancelling 11 from both sides. But again be careful, we can do so because 11 is a non-zero real number. You can cancel a non-zero real number from both sides of an inequality, just like you can cancel such a number from both sides of an equation. But even more than that, the inequality will remain unaffected. That is, it will not be flipped if the number you are cancelling is positive. But if it is negative, then it will change direction. In this case 11 is positive, so no problem, and that way you get x less than 6. So the solution set consists of all real numbers which are less than 6. That means this is the solution set. All the real numbers which are less than 6 give us this open interval minus infinity comma 6. Number 10 has this inequality, x divided by 3 is greater than x divided by 2 plus 1. So here also we do a similar thing as the previous one. Instead of taking LCM or anything, we multiply both sides by 6. So that way, oh, and one more thing, because 6 is positive, so the inequality maintains its direction. And then after you do the cancellations and do everything, the left hand side becomes 2x and the right hand side becomes 6 divided by 2 is 3, 3x plus 6. And then you subtract 6 from both sides, getting minus 6 on the left hand side, and simultaneously you subtract 2x from both sides. So that way you get 3x minus 2x on the right hand side, which becomes x. So the solution set consists of all real numbers less than minus 6 which give you this open interval minus infinity comma minus 6. Next, number 11, here the inequality is 3 times x minus 2 divided by 5 is less than or equal to 5 times 2 minus x divided by 3. So they are becoming more and more complicated. So we write the given inequality. Now you can see that you have 5 and 3 in the denominators here. So to simplify it, we multiply both sides by 15, because 15 is positive, the inequality maintains its direction. And then you do the cancellation. Here you will get 3. 3 times 3 is 9. So 9 times x minus 2 is less than or equal to, here the cancellation gives you 5. 5 times 5 is 25. It is less than or equal to 25 times 2 minus x. So then you do the multiplication. 9x minus 18 is less than or equal to 25 times 2 is 50 minus 25x. And then you add 25x to both sides. That way here you get 9x plus 25x, and simultaneously you add 18 to both sides. That way you get 50 plus 18 on the right hand side. The left hand side becomes 34x and the right hand side becomes 68. And 34 times 2 is 68. So dividing both sides by 34, again which is positive, so it does not affect the inequality, you get x less than or equal to 2. So the solution set is this unbounded interval. On this side it is closed because it is less than or equal to 2. 2 is a solution. Next, number 12. So here it's a little more complicated. 1/2 of 3x divided by 5 plus 4 is greater than or equal to 1/3 of x minus 6. Okay, so we of course write the inequality. Now if we follow what we have been doing so far, what is it that we have to do here? Because you have 2 and 3, so you naturally would multiply both sides by 6, but that will not simplify the inequality fully because you have 5 here as well. So keeping that in mind, I decide to multiply both sides by 2 times 3 times 5, that is 30. So that gives me what immediately? Oh, and one more thing, because 30 is positive, so the inequality maintains direction. You have to always keep that in mind. Of course, we have been getting inequalities where we are multiplying by positive numbers, but sometimes we may have to multiply by a negative number. When you have to, do not shy away from doing that. Just keep in mind that whenever you multiply by a negative number, the inequality just gets flipped. That's it. Now, however, it's positive. So 30 divided by 2 becomes 15. On this side, 30 divided by 3 becomes 10. And then when you further multiply this thing by 15, and that's why we chose 30, not just 6. What do you get? 15 divided by 5 is 3, 3 times 3 is 9. 9x plus 15 times 4 is 60. On this side you have 10x minus 60. So then you add 60 to both sides and also simultaneously subtract 9x from both sides, which gives you 120 on the left hand side and the right hand side becomes x. So here the solution set consists of all real numbers less than or equal to 120. That is why it is this interval closed on this side, minus infinity comma 120. Next, number 13, where the inequality is 2 times 2x plus 3 minus 10 is outside, is less than 6 times x minus 2. So this one is very easy. There is no twist or anything. You do not even have to multiply by anything. So you just simply simplify the left hand side. You do the multiplication. 2 times 2x is 4x, 2 times 3 is 6, and minus 10 already is there. On this side you get 6x minus 12. Then 6 minus 10 becomes minus 4. Actually I should have written one more step, but you can understand what I did here. 6 minus 10 is minus 4. We subtracted 4x from both sides. which gave us 6x minus 4x on this side, and on that side there is no x. But simultaneously we have also added 12 to both sides. So on this side no 12 anymore, on this side we have plus 12. Now 12 minus 4 is 8 and 6x minus 4x is 2x, and finally you divide both sides by 2. Again 2 is positive, so nothing changes. The inequality does not change its direction and you get 4 less than x. So the solution set consists of all real numbers greater than 4. So that is this open interval 4, infinity. The next one is 14, where the inequality is this: 37 minus means minus of 3x plus 5 is greater than or equal to 9x minus 8 times x minus 3. So I am leaving this to you, and this is the hint. The solution set will be this closed unbounded interval. Perhaps I should not call it closed, but closed means closed on this side, minus infinity, 2. And the next one is this: x divided by 4 is less than 5x minus 2 divided by 3 minus 7x minus 3 divided by 5. This one also I am leaving to you, and this is the hint. The solution set is open interval 4, infinity. And now finally we are going to solve the last one. Last one means last one for today, and that is number 16, where this is the inequality: 2x minus 1 divided by 3 is greater than or equal to 3x minus 2 divided by 4 minus 2 minus x divided by 5. Okay, so we write the inequality term and then we decide what we have to multiply this by. If you want, you can actually take LCM and do the usual stuff, but let me just continue that multiplying thing. We have to multiply both sides. If we really want to get rid of fractions, we have to multiply both sides by 3 times 4 times 5. 4 times 5 is 20, 3 times 20 is 60. That's what we did. So 60 divided by 3 is 20. So 20 times 2x minus 1 is greater than or equal to 60 divided by 4 is 15. 15 times 3x minus 2 minus 60 divided by 5 is 12 times 2 minus x. And then we do the multiplication. This is 40x minus 20. 3 times 15 is 45. 45x minus 30 minus 24 plus 12x. And then in the next step we do 3 things simultaneously. The aim, of course, is to bring all the terms having x to one side and push everything to the other side. That's the aim. So here there are 3 terms having x: this one, and this one. Instead of doing this addition, 45x plus 12, well, actually you can do, but because you have 40x on that side, so things will be simplified if you bring that 40x over to this side. Bring that over to this side means, of course, there is no physical motion that it's coming from that side. It just simply means subtracting 40x from both sides. So doing that, you get 45x minus 40x plus 12x on this side. Similarly, on that side you have minus 20, on this side you have minus 30 and minus 24. So the other 2 things you do are these: you add 30 to both sides and you add 24 to both sides. So that way you get 24 plus 30 on the left hand side along with minus 20. Now 24 minus 20 is 4, 4 plus 30 is 34. 45 minus 40 is 5, 5 plus 12 is 17. And then you divide both sides by 17. 17 is positive, so the inequality retains its direction and you get 2 greater than or equal to x. So the solution set is this interval. It is the set of all real numbers less than or equal to 2. 2 is included. So it's closed on this side and open on that side, of course.